Today we're going to learn about exponential growth functions. On the left-hand side, we have the function equation for exponential growths. So I want you guys to write that down, but I also want you to know that an exponential growth is when a quantity increases rapidly over time. So we're going to see a lot of graphs that, swoop up very quickly. So from our equation, we're going to write what the y equals, the a, the r, just so you know what that means. So y is the final amount that we're talking about. Okay. A is the initial amount, so the starting place, and R is going to be the rate of growth, okay, and we're going to see it in decimal form. So we're going to talk about percents. It's the rate of growth, but it's going to be in a decimal form, okay? So if we have a growth of 2%, it's going to be 0.02. That's what we're going to talk about today. And then T is talking about the amount of time, okay? So that's going to be very important to us too, because we're going to talk about, okay, so what happens after a certain amount of months or years or whatnot. So T deals with time, just so you guys know what to plug in. Now we have this first equation or example, and it says the function of y equals 150,000 1.1 T represents the attendance at a music festival T years after 2010. So it says, by what percent does the festival attendance increase each year? So what I want you guys to really look at is what's inside the parentheses. Because if we're looking at our original equation, that is what's called the growth factor. So it's really the number one plus the rate that we have. So we're going to set those equal to each other. So I have 1 plus R equals 1.1. We're trying to find the rate of the increase. So basically we're going to solve for our rate, our decimal form percentage. So I subtract 1 to both sides, and I get that R equals 0.1. Now remember, the rate is going to be the percentage of growth in decimal form, but they're wanting the actual percent. So we have 0.1 as your rate, but that also means if we move the decimal twice over, it's a 10% increase of the festival attendance each year. Now the last question says, how many people will attend the festival in 2014? Round your answer to the nearest 10,000. So let's talk about this, because we're now going to plug in something for our time, our T. Now, our T is talking about the music festival, however many years after 2010, so we know that T is going to be 4. 2014 is 4 years after 2010. So all we're going to do is we're going to plug in 4 for our little exponent T. So I'm rewriting the equation that we are given in the problem, and I'm going to plug in a 4 for our time. So I'm going to do 1.1 to the 4th power, and in my calculator I am given 150,000, that's a comma, sorry, times, and I'm given 1.4641. So now I'm going to multiply that to 150,000, and I'm given that the actual attendance is going to be 219,615. It does ask for us to round to the nearest 10,000, so that's the 10,000s place. So it's actually, the attendance is going to be 220,000 people. And that's your answer. Go ahead and try to complete this next problem on your own. It's talking about members of a website over time, especially years after 2010. So go ahead and find the percent of increase each year, and then talk about how many members will be on the website in 2016. And this time you're going to round to the nearest 100,000. So it's just like the previous example. See how you did by checking back on the video. All right, so these are the answers I received. The membership increases 15% each year. So we just had to figure out what our rate of growth was. So I did 1.115 equals 1 point R. So by subtracting the 1, I had 0.15 equals my rate of growth. However, that's in the decimal form while we wanted the percent. So I just converted that. Then I plugged in a 6 for our time in our second problem because they're wanting to know how many members there'll be in 2016, which is 6 years after 2010. I rounded to the nearest 100,000, and I got 1,200,000 members. The next thing we're going to cover with exponential growth is the compound interest equation. So what that is it's earned on a principal, this compound interest, and it's talking about different account balances that we're going to see. So I'm going to tell you what each variable means, and then we're going to start plugging things into it. So Y is your final amount that we find in different problems, so just as we did previously. Now P is talking about the principal amount. So that's the maybe the amount that you added to a bank account initially. The R is the annual interest rate. So that's going to be something that's applied annually. So annual interest rate, and it's also going to be in decimal form. So if we had a 3% interest rate, it's going to be 0.03. And then T is going to be, of course, as we talked about, time. And this time it's going to be in years. We're talking about over a year span. And then N is going to be the number of times that your money that the interest is compounded per year. So if they say monthly, well, that's 12 times per year. If it says annually, that's 1 time per year. So you're just going to plug in what you know. So let's start with this first equation to start plugging things in. It says you deposit $100 in a savings account and it earns 5% annual interest and it's compounded yearly. So write a function for the balance after T years. All we're going to do is plug in what we know. Well, the 100 is our principal amount. That's the amount that we initially put into our account. 5% annual interest, well, that's going to be R, except we have to put it into our decimal form, so it's 0.05. And then if it's compounded yearly, well, that's going to be our N, and it's the amount of times it's compounded per year. Well, since it's yearly, it's 1. So we're going to plug in what we know. So I have that Y equals our principal, which is 100 times 1 plus our rate, which is 0.05, divided by the number of times it's compounded each year, which is 1. And then I have the same N times T. All we have to do now is just simplify this problem. So I'm going to worry about what's in the parentheses first. So 0.05 divided by 1 is 0.05. So I'm just going to go ahead and add it to 1. So it's 1.05. And then I'm also going to worry about my exponent. So 1 times T is just T. So this is the function that we end up with, which looks just like a regular exponential growth function. So we see that it increases by 5%. We put in $100 primarily. For this next example, we are given a table. You guys do not have it in your notes, however, it's here in the video. And what we're going to do is the same thing. We're going to write a function for the balance over a certain amount of years. So we have to talk about what we need to know. First off, we need to know what our principal payment is. Well, our principal, after 0 years, we had $100. That's great. Now we do have to figure out what our rate is in decimal form. So the way that I'm going to do this is I'm going to figure out what the difference is between each year. So if I went from $110 to 121, I need to know the rate. If I went from $100 to $110, I need to know the rate. So by doing that, I'm going to just divide. 121 divided by 110, or you could do 110 divided by 100. So when I do that, I have 1.1. So that's actually going to be my rate completely, okay? So the rate itself is growing at a 10% increase, okay? But by multiplying it by 1.1, it's increasing each time, okay? And then since it's not talking about when it's compounded, we're going to say that it's compounded each year, so our N is 1. So when we plug it in, we have Y equals 100 times 1 plus 0.1 divided by 1 And then we have, again, our n times t. So it's 1 times t. So again, we just kind of simplify inside our parenthesis, which honestly we have already figured out when we divided our two numbers that our growth rate was 1.1. So y is equal to 100 times 1.1. And then again, 1 times t is just t. And that is our equation for this exponential function. Go ahead and try the next one. So this next one's talking about a deposit of $500. It earns 4% annual interest and it's compounded yearly. Now it does say to write and graph a function. I just want you to write the function as practice. Check back and see if your answer is correct. All right, so this is the answer that you should have gotten. It is earning 4% annually. So by multiplying our $500 by 1.04, that's going to show our growth. And then we do not know a year yet, so we're going to plug in t for years. And that's what you should get.